Hi everyone, I'm Brad Boa. Let's look at this physics problem. Two springs initially or with relaxed length 0 are each stretched a distance L, and they both have a spring constant of K. This first spring is attached to the wall and then to this mass right here, and this spring is attached to this first mass right here and this second mass right here. So someone is holding it like this, and then the question asks, right after releasing these two masses, what are their accelerations? So first, we need to examine the net forces on each ball. So let's draw the free body diagram for this first mass right here. For this first mass, and then you can assume there's no gravity. Yeah, so then we're only examining left and right forces. So this spring right here will pull it with the force of K times L. And the spring will pull it in the direction so as to make the spring its original length. So since it was originally 0 length, the spring will pull it in this direction, while this spring will pull the mass in the other direction, so that because the spring is trying to compress back to 0. If the spring's relaxed length was initially longer, say this spring was initially longer than L, then this scenario is compressing it, so then this spring would be pushing the mass that way. So I would have drawn the force in the other direction. But in this case, since both springs' relaxed lengths are 0, this spring is pulling it this way, that spring is pulling it this way, with the force of K times L. And then for this mass right here, draw it right here, the only force pulling on it is this spring with the force of KL. So for this first ball, you can obviously tell these two forces cancel out because they're equal in magnitude, opposite in direction. So let's draw the F equals ma equation for this first ball. For ball 1, I'll draw it up right here. For ball 1, we have F equals ma, the net force equals ma. So that means 0 will equal m times acceleration of the first ball. I'll say a1. So a1 equals 0. Now let's do F equals ma for this second ball. We have ball 2, the net force equals ma. This K times L is the only force on it, so that's the net force. KL equals n, I'll say A2, the acceleration of the second ball. So then A2 equals K, L, all over n. So there are your two answers.